Hey AP Calculus people, we're going to start by looking at your chapter test and questions 1 through 3. So let's get right into it over here. Well, apparently I need to zoom in. So evaluate this integral, and for everything that we're going to be doing in this chapter, when it asks you to evaluate an integral, there's going to be, you're going to have to find a way to turn this into a more basic function. So looking what I have right here, I've got a quotient rule, and there is no quotient rule for integrals. So once you accept that, then you have to realize that there is going to be a way to simplify this. So let's take a look at this integrand. 4 plus 5x to the 3/2 power over, and I'm going to turn that to x to the 1/2 power. So algebraically, this is equivalent to 4 times x to the negative 1/2 power plus 5x. So if I want to integrate this, integral 4 plus 5x to the 3/2 power over root x dx, that's going to be equivalent to integrating 4x to the negative 1/2. That's not a good looking negative 1/2. Negative 1/2 power plus 5x dx. Now we're all kind of in the basics here of integrating things, so I'll remind you of the power rule for integration. The integral of x to the n power dx, that's going to be 1 over n plus 1 x to the n plus 1 plus a constant. So let's see what we have here. We've got that 4, which is just a constant multiplier. I'm just going to stick that out in front. Now x to the negative 1/2, in this case n equals negative 1/2. N plus 1, that's going to be equal to positive 1/2. So this is going to be 1 over 1/2 x to the positive 1/2. Multiply. Plus, now for this one, second one that we have here, 5x, again, we'll just take that constant and lay it out in front. And this is x to the first power, so if n equals 1, n plus 1 equals 2. So this is 5x to this 5 times 1 over 2. Make sure you have that multiply sign there. X to the 2 power. And then we'll put the plus constant at the very end. Now, simplifying that, 1 over 1/2, that's the same thing as 2. 4 times 2 is 8, so 8x to the 1/2 power, plus 5 times 1/2 is 5/2, x squared plus constant. So this is our antiderivative of number 1. Number 2. This one is one of those properties for integrals, and it's actually one of the more useful properties. Let's take a look at the limits. We got 0 to 9, 3 to 9, and 0 to 3. So if I want to put these in order, I think the lowest one I have is 0. Yeah, the lowest limit is 0, and that goes to 3. So 0 to 3 of f of x dx. Plus, now the next one is 3 to 9, so the integral from 3 to 9 of f of x dx. Wouldn't you know that? That's the same thing as the integral from 0 to 9 f of x dx. Okay. Again, the upper and lower limits match over here, and then the 3's match on the interior. So this is a true statement, and now we're just going to substitute things that we know. So 0 to 3, that's actually unknown, so I can't really substitute anything for that. I'll just rewrite it. Plus 3 to 9, I know that that's negative 1. So I'll put a negative 1 there. And that's equal to 0 to 9. That's equal to 5. So with some basic algebra here, we can get that the integral from 0 to 3 of f of x dx, well, that's got to equal 6. So that's our question 2. And finally, with our question 3, we're going to have this function f of x equals to an integral. So this is a function defined by an integral, and we're supposed to find the derivative. So I'll just remind you here that if the upper limit matches with the variable of differentiation, then you're just going to substitute the upper limit. Of course, in this case, they're not going to match. I'll show you. 1 to x squared t cubed plus root t dt. So take a look at this. X squared. Not exactly the same thing here. This needed to be just a regular x. So I'm going to utilize a variable substitution. I'm going to say u is equal to x squared. So what that does for me, that means that this derivative here that changes this upper limit to u, and nothing else changed. But that enables me to use a chain rule, because if I want to take the derivative of something with respect to x, that's going to be equivalent to taking the derivative with respect to u. And I really should have kept that in green. So we're going to take the derivative with respect to u now. And then we're going to multiply by du dx. This is the chain rule for derivatives. Okay. So if I'm doing that, then all I need to do here is, now that these two do match, u and u, we're just going to substitute u into the integrand. So the integrand is, well, that's a u cubed plus the square root of u cubed plus the square root of u. And then now we're going to multiply by du dx. Well, what is du dx? Well, if u is x squared, du dx is 2x. So we're going to multiply this by 2x. The only thing that's left for us to do here is to substitute, because we knew u was x squared. So this is the same thing as x squared cubed. Let's make those green so you can see that that's where it came from. That's x squared cubed plus the square root of x squared multiplied by 2x. Now that is the correct answer, but the simplification here probably leaves a little bit to be desired. So let's simplify this just a little bit, and then we're probably going to simplify it a little bit more. So x squared cubed, that is x to the 6th power, plus square root of x squared is just x multiplied by 2x. And yeah, I think I can factor out another x. So if I factor out one more x, I get 2x squared plus, 2x squared multiplied by the quantity of x to the 5th plus 1.